Okay, good evening. Right, so let's start our lecture 2. But before we go into lecture 2, let's continue. Right, last week we actually stopped halfway. So let me just continue from last week. Okay, so we find last. Okay, so this is us jumping back to last week's notes. Okay, so we stopped at the end of last week. So let me just highlight to you, okay, while we still wait for the rest of the students to come, we talk about some things we talked about last week. Okay, so in C, okay, you recall that all statements must belong in the function, right? Sometimes you see people declaring variables outside functions. Okay, that means this variable, the scope of the variable is global. Okay, so we're not talk about those kind of global functions at the moment, right? For now, let us just take the assume that all statements, everything you write, okay, must be inside a function. Okay, to recall what's a function, function is just like a mini program, right? So you have a mini program. There's some inputs, right? And then at the end, it produce some output. Okay, so that's a function. It's a mini program with instructions in there. Okay, statements. So all statements have to belong to a function. Now in C and C++, for your entire program, so a program is definitely made of many functions. Right? You can have one function, two functions, many functions. If you want your program to run, you need to have this special function called a main function. Right? So the main function will look like this. Okay, so the type is int, and you always return 0 at the end. Return 0 at the end tells the operating system that your program has no error. Okay, so I mean, of course, your program is free to return any integer. Basically, it tells the operating system that your program terminated with some error. Okay, but normally there's no error, we just put 0. Input for now is a void. Okay, so if you put void here, it means it takes no input. Okay, in C or C++, even if you don't put a void here, you just put open and close bracket, it is the same. Okay, so this is the syntax of the main function. Basically, this is the entry point of the program. Right, when you compile and run the program, this is the function that the operating system will start. Okay, we'll talk about what does it mean by compile and run in a moment's time. Okay, so basically the inputs and output is what I said. Okay, so this one, I mentioned it last week. Right, currently cosmology only requires you to code the relevant function. Okay, it does not need you to code the entire main function. If you put the main function in cosmology, you get error. Right, like I said, there can only be one main function in the entire application. Right, cosmology, you can view it as one big application trying to run your code. So if you put a main function in your solution, then it means there's two main functions, right? The first main function is the entry point for cosmology to process. So if you put a main function, then there'll be error. So what you actually want is just put the relevant function. Okay, so cosmology will have its own main function, you run the thing, then somewhere along the line, it will call your function, and your function will produce a required output. Right? So cosmology will call your function with various test cases, as you can see. Right, so this is some example template which you will see, right, from your mission. Okay, so in your mission, you will have an example template like this. Okay, so when you run a template, we provide you this main function, because when you execute this in Visual Studio Code, okay, you need to be able to see I mean, Visual Studio Code needs to run your program. After you compile, your operating system needs to run the program. It needs to have this main function. Then you'll call this function, right? So you call it 72. So basically, this will call this function with 72. All right. So this weekend's lab, I'll talk more about lab later on. So this weekend lab, we will experiment a little bit of the cosmology. Okay, your tutor will guide you through it. Okay, these are comments. Okay, indentation, I mentioned this previously already. All right, so this is where we actually stopped last week. Okay, so what does it mean by compiling code? So you realize in your first problem set 0, we need to install two things, right? The first one is the Visual Studio Code, which is an editor. So for you to write your C code. So C code is nothing more than just text files. You can also use Notepad to open and write. But of course, Notepad doesn't have all the nice color, fancy highlighting and all that. Okay, so Visual Studio Code is able to understand C programs and change the color of the words. Right. So you need an editor. Now, it turns out that your computer, okay, so CPU is your computer. It is the central processing unit. We will learn more about this CPU in the computing topics. I think next week we'll start talking about this. Now, your CPU does not actually understand C code. All the C instructions that you write, it does not actually understand. What it understands, it is its own machine code. Like binary, all the ones and zeros on the machine code. Okay, we'll talk more about that when we talk about computer organization. So different CPUs, okay, will use a different machine code. So Intel and AMD, okay, so Intel i386, okay, this is a 32-bit machine code. AMD 64-bit machine code. PowerPC, ARM, okay, will have its own machine code. Okay, right now I think most of you have heard ARM because Mac, Apple is going to change from Intel to ARM. Right? If you use Apple from a very long time ago they were using PowerPC CPUs. Then they moved to Intel. And from Intel now they're moving to ARM. Okay, so these are all the different CPUs, right? So each CPU manufacturer will have their own special instructions. Okay, so your machine only understands this instruction. So what do you do? If your humans write in C code, machine code is too difficult for humans to read. Okay, very difficult to read. So what happens is we have this step called a compilation process. Compilation process, basically, it will translate your C language code into some machine code. Right, so if you're writing code in C#, C++, right, you have some kind of compiler, it will compile your code into a machine code. Okay. So what is this edit, compile, and run cycle? So what happens is this: you will start writing code in your text editor. So you have this thing called program.c. Okay, use an editor to write this. In our case, we use Visual Studio Code. Okay, to write this. Okay. Then you do this kind of compilation process. So a compiler, so I asked you all to use a GCC compiler, or for Windows, you use a GCC compiler. For Mac, you will use your Mac CLang compiler, take a Clang compiler. This compiler will generate this binary code, which is machine code. Okay, so this is the machine code, or they will take some other binary code, okay, and they'll link together. Okay, we'll talk more about this linking thing in later parts. Okay, not so much to do with programming, more computing, and then you get this executable file. On Windows, you will see a .exe. So this file is an executable file. Right? So when you try to email executable file, normally your Gmail or email will block because this file will execute instructions. Okay, on your computer, you can execute instructions like delete all your files or corrupt your stuff. Right? So it's very dangerous to anyhow run executable files. So some of you have realized in your own Visual Studio Code, when you try to write on program, your antivirus stops you from executing because it is preventing you from running any executable file. Okay. So yeah, you have an executable file in your machine. So depending whether you're running on Intel, okay, or under Windows or Mac OS, okay, this the process, your computer, your OS will take this executable file and execute it, run all the different instructions. Okay, so that's how your C program goes to being executed. It goes through many steps, or rather just two steps, the compilation step and then the final execution step. All right, so this is the main overview. We will go a little bit more into it when we talk about computer organization. Okay, now with that, I will briefly talk about the history of C. Okay, because we are using a C and C++ language. Okay, let's talk a little bit about history of it. Okay, so C actually, okay, before C, what came before C? Right, so C, what came after C is C++. Okay, because C, then you add on stuff to C, you become C++. What comes with, before C? Okay, my son will tell you B. Right, B comes before C. Okay, so what comes before B? Okay, it's not A. Okay, it is BCPL. Okay, it is some kind of programming language. I don't know, binary, something compilation language. Okay, so they have this BCPL, and then from there they wrote B. Okay, so they call it B. Then they improve B to become C. So this one is just basically after B comes C lah. So they are just trying to be a bit smart about it. Right. Then they add on modern object-oriented stuff onto C, and they call it C++. There's some D lah. Someone trying to write D or something, but actually didn't take off. Okay, so D didn't take off. So this is the history of C. Okay, now even with C, okay, there is some this is not evaluation, it should be evolution. I think I spelled wrongly. Okay, it should be some evolution of C. So C started development 1972, way long ago. Okay, then in 1978, K and R, they formalized the C programming language. They published a book, okay, on called C programming language. Then in 1989, the ANSI standard, the American National Standard Institute, right, okay, they formalized ANSI in 89. But at the same time, ISO came out with adopt the standard called C90. Okay, so C as a programming language is now ISO. So the ISO controls what the programming language is. Okay, this is different from some other programming language like Python. Python, the author of Python, okay, controls and determines what is to be done. Okay, so but for C is ISO standard. So every few years they have a certain standard. So C999 is called C99. The 2011 is C11. So there's C13, there's C18, right? So that means the standards are formalized in the year. Okay, so as the time goes on, C as a language, okay, becomes more formalized. Now, the funny thing about standards is that even though we have international standards, people don't always agree on the standards. You can imagine like a browser war, right? So the browser, they have this W3C, right? World Wide Web Consortium, who is supposed to uphold the standards of what a browser is supposed to doing. But as you know, Apple does its own thing with Safari. Microsoft used to do its own thing with IE, now become Edge. Chrome, Google's Chrome used to do its own thing, right? So even though you have standards, at the same time, people write program, they don't follow your standards, you can't sort of blame them. Or rather, they can say, oh, I follow your standards, but I add additional features. Right, so that's the funny thing, right? So it's like in a browser war, right? Maybe Mozilla Firefox follow the standard, but they add certain feature to make your experience, to make the user experience better. So web developers, okay, they will go and adopt this feature, right? So it becomes a case of my browser has more features than your browser, even though we follow the standard, we have more things. So the same thing with compilers. Okay, so compilers, okay, basically, as you can see, I use handful analogy. Every revision of a compiler, okay, they add more and more features to it. Okay. That means if I have certain code written for C11 and I use a C90 compiler, it might not compile. Which is why in your problem set 0, I ask you to run this example code, okay, to check, make sure your compiler at least meets C11 standard. Okay, because C11 standard, again, like I said, there's some features, and these features oftentimes make your life a bit easier. Okay, the code make it easier to read and all that, right? So we use a little bit more modern stuff. I mean, no reason for us to be still going back to the 1990s. In fact, C11 is already more than almost a decade old. Okay, so the problem with this is like your browsers, different compilers have different features. So as you can see, there's a lot of different compilers. Turbo C and Boolean C was very old, right? Long time ago. Nowadays, there's like 3 different main compilers that are left behind, which is your GCC, your GNU compiler, right? Which is I ask you all to install. Apple users will be using your Clang, okay, CLang LLVM compiler. If you use Microsoft, so if you install Microsoft Visual C or Microsoft Visual Studio, not the Visual Studio Code, right? It comes with its own C compiler called MSVC. Now, all these compilers, they follow the ISO standard. Okay. However, some of them, again, add their own features. And they all tend to do things a little bit differently. So the ISO standards is actually very loose. Okay, certain things the ISO leaves undefined. They said, oh, your compiler it's up to the compiler how you want to interpret, right? So, for example, if a certain instruction you put, then this is not a correct instruction, your compiler can decide what it wants to do. Okay, for example, last week we talked about when you initialize a variable, right? You say integer, okay, when you initialize a variable, integer, oh, okay, say I put integer I. Okay, when I said you last week when I talked about initializing a variable or declaring a variable, right? I said we should as much as possible write it this way: integer I equals 0. So at least we know the integer I contains 0, right? But sometimes you don't, right? You write this way. So what does I contain? So according to the ISO standards, it says this is undefined. You can do whatever you want. So most compilers will just ignore, right? It will just define I to be whatever is there in the memory. Okay, this time we look at it in more details when we talk about the memory. But certain compiler, I think maybe the C-Link, okay, maybe this compiler, they will try to be more smart for you. They say, oh, you didn't initialize, never mind, I set to 0 for you. Right, so this is where the discrepancy come in. Like some compilers, they literally follow what the ISO standard says. This is not defined, so we can assign any rubbish value to it. Right, so if you try to do I plus 1, so any rubbish value plus 1, then we get rubbish value lah. Okay. However, some compilers try to be smart. They will initialize this to 0 for you. So when you do this, oh, okay, it will just be 1, right? So normally what we want to assume is this: some compilers will take the extra step to correct some of these mistakes, so-called mistakes lah. Now, why is it important? Because I think, or maybe the other way, I think GCC maybe is the one that initializes to 0 for you. So if you are using Windows and you're at home and you forget to initialize your variables, right? GCC will assign some default values like 0 to them. Then you write your program, you run, oh, everything's okay. Then you go and submit on Cosmology. I think Cosmology is running your Clang LLVM or some Linux compiler. Cosmology might not be so kind, right? Then your program will not work because the way it handles all this uninitialized value is different. Right? Then you will complain, how come it work on my computer, it doesn't work from yours? And so this is like the common complaint you will hear like programmer. Why it work on my system? I don't know what's wrong with your system. So sometimes it's to do with the different compilers. Okay, so this is the issue we see. If you are dealing with Java, Python and all this, so Java, Python, not so much of this problem because in a sense, their language, those languages are not compiled languages. Okay, we might be able to look more into it when we talk about this in the computing topics. Okay, so Java is this thing that where they try to make it is this goal where they write this language such that on any computer, any system you run, the execution will be the same. That's just what Java is trying to do. Whereas for C, you must realize it requires compilation into native code, and depend on which compiler you use, right? The behavior might be a little bit different. Okay. Oh, this is the thing with C. Okay, so each have its favorite default. Okay, so for our class, okay, we will use C11 standard. Okay, okay, we don't have, we have labs lah because now due to this circuit breaker we cannot attend labs, right? So on your own, just be mindful. Okay, whichever compiler you use, there will be slightly some quirks. Okay. Okay, so far so good. Okay, let's now start going to our lecture 2 content. Okay, so far any question? Okay, if no question, then you can click all good so far, give me a yes. So Zoom got a yes thing. So even though you all turn off your video, at least you put a yes, I can see you are responding here. Some of you type yes. Okay, no problem. Try not to chat yes because maybe you type yes, then some student ask question, then it goes away lah. Try to use the yes no thing on Zoom. Can you find it? So you have this, I think it's under participants. If you open participants, you can click yes, no, right? And you can see the things there. Yeah. So you all found it and you put a check mark. All right, let me switch to the lecture 2 slides. Okay. Okay, interestingly, I noticed some of the names is just your email address. So I'm not sure what's wrong up with that. Okay, it has all refreshed. Okay. No, there's still some usernames with email address. Okay, let's talk about lecture 2 control structures. So this is a reminder of today's lab. So okay, I talked a little bit about the allocation. So it turns out originally there was four there was 4 mornings. I want to I'm right slower. Four morning slots, okay, and 2 afternoon slots. But turns out I think this was a mistake in allocation, okay, because one of your tutors, I have to co-teach with one of the tutors, so we cancel this to 3 morning slot, right? So the outstanding class was distributed into the remaining 5 slots, right? So this is our allocation. Now the afternoon slot, I think there are 2 special timing. One is earlier than the other. Okay, So, but for today's lab, for this Saturday, I think we just fix it at 3 p.m. Okay, I will tell the tutors to just fix it at 3 p.m. All right, 3 p.m. to 5 p.m. Okay, so the morning session I think is 10:30 to 12:30. Okay, because it's supposed to start at so tutorials is supposed to be 1 hour before. So this weekend we do not have any tutorials. Okay, we only have lab. That said, this lab, like I say again, this lab will go through some basic housekeeping thing. Your tutor will teach you how to copy code in cosmology, how to run the program, right? Then maybe help you tackle some of the problem sets. Now, if you are very good or you finish the problem sets, no problem with coding at all, right? Then this lab you don't have to come. Okay, so this lab is optional. We will not take attendance for this lab. So if you think that everything here you can do, so no need to waste your 2 hours or spend your 2 hours here listening to things you already know. Okay, so if you have problem, they come to this lab. All right, so labs are optional, but tutorials we will require. We have attendance taking for tutorials, in the sense you'll be given participation EXP. Okay, so someone asked whether is it 3 to 5 for all weeks. No, only for this Saturday. Okay, so yeah, so you can come. Okay, so you are assigned to actually you're already assigned to an existing lab. Okay, I will do the tutor allocation, then you can figure out who is your tutor in which lab. Okay, so how to contact your tutor? I think when you come to the lab, okay, you'll be able to see your tutor there, right? No, the lab Zoom link will be different. Right, so each tutor will provide me his Zoom link. Right, so there will be 5 different Zoom links. So they will use this each. I think every week you use the same Zoom link for your lab, but I can't use the same Zoom link because you all have all different classes. Okay, so only for this week, the afternoon one, I think okay we'll hold it from 3 to 5. Unless okay, is there anyone who you belong to the 2 to 4 one? You can't make it because you plan something at 4 at 4. Okay. Yeah, so you're in group 4 only by this Saturday. Yes, so I will do the tutor allocation. Group 4 I think is one in the morning lah. So one of the tutors will be there. Okay, so this one I will have to submit the names to scale. Okay, how to check which group you're in? I think Luminous or your EduRec will show which group you're in already. Okay, so just go to Luminous or go to EduRec, right? Then you will see it. Where to get Zoom link for the lab, right? I will collect from all the tutors that are post as an announcement. So similar to the lecture Zoom link, right? It's on cosmology as a sticky announcement, it's stuck at the top, right? So our weekly labs also I'll put it there as a sticky, right? So anytime you cannot remember, you go to cosmology and refer. It should be the top announcement. Okay. So again, this is a textbook. Okay, I don't want to talk about it. I talked about it in the first lecture already. All right, there's some incorrect practice. I think this year I don't see a lot of students doing this, but this one have a problem. Okay, I think it's done with Visual Basic tend to do this. Basically, your function is called F to C. Then you try to assign create a new variable with the same name as a function. Right? In C we don't do this. Okay, C we don't do this. I think in Visual Basic the way you set the output of the function is to assign a value to the function name, and I think that's what is done in Visual Basic. Okay, but this is not Visual Basic. So in C language, to set the output, we just use this return command. Okay. Okay, I'll talk a little bit about displaying on screen now before we go into the content. So displaying on screen. Sometimes you want to view your output of your C program. So there are 2 ways of doing it. The first way is to use this command called printf. Okay, so you type printf, then you open with a quote and with a quote. So whatever is in a quote, this will be displayed as a string. Okay, we call this string. Basically, think of it as just text. Okay, it's called a string literal, or I can say it's literal text. Okay, so the text will appear on the screen. Okay, now if you use printf, you must put this line here at the top of your program. This is called declaration. Okay, so what this declaration does is, oh, someone's drawing on my screen. Maybe don't draw my screen. If not, it'd be hard to see. Where is the mouse? Okay. Mm, let me just clear all. Okay. So now this is predefined directive. Okay, oh wait, this one is zooms. Yeah, why Oliver can draw screen? Because I didn't disable it. Okay, so I disabled it already. Okay, so this directive means that, okay, where does this printf function come from? This printf is actually a function. This function actually comes from this prepackaged library, right? So it's telling C that, oh, go to this library called standard IO, standard input output, and use the printf function from there. Right? Because we did not define a printf function. Someone must define it. So there's some complex function to allow the words to be shown on screen. So this is the C method. C++ method, instead of using printf, we use this thing called cout. So notice the syntax is different. What you do is use double arrow. So you take this hello world, you sort of like shove it into this cout. Okay, this endl is the new line. So you notice here, this is a new line. Okay, so this is what the new line is. So if you're using C++, then you put this inside here. All right. Now, because we are using C++, anything in C++ is backward compatible to C. So even if you want to use the C method, you can still do so. Right? C++ is backwards compatible. Right? So why do we have these two different ways? Well, they are a bit they work a bit differently. Okay. So let us try to see how we will display numbers. Okay, this one is very simple. This is just a string literal. It means whatever you type within the two quotes, it will appear. Okay, these two quotes must be on the same line. You cannot put on a new line. The compiler will complain. Okay. Now, what if you want to display variables like numbers? So say I have an integer I here. The printf version is this. Let's take a look. The value of I is %d. Oh, notice my text literal, the string literal, doesn't have the number inside. It doesn't have the value of a variable I inside. But yes, this %d. Okay, so this %d is like a placeholder because you notice here, comma I. Well, you can intuitively think this I will definitely be substituted into this D, right? So it will display it. Down here, notice this printf, we have 1% D, 2% D, 3% D. At comma, at the back, we have 3 inputs. So yeah, so your A will go to the first one, B will go to the second one, and C will go to the next one, right? So intuitively, this is what happens. Okay, so the printf, what you do is called formatting. So printf, the F stands for formatted. Okay, so print formatted, what you have is all these extra things you put inside. Now, this %d is only for use with integers, meaning whole numbers. Right? If you want to display a double, you must use %f. Right? Then this will display 2.5 correctly. Now, the problem with C is that it's not type safe. Means if here you put, you didn't put %f here, you put %d. Okay, you by mistake put %d. Then this d is a double, right? Where you try to reprint, it will go here, and then funny things will come out. Okay, nonsensical numbers will appear. That's the problem, right? This is not type safe. Means you put the wrong type. Depend again. Some compilers will complain. Some compilers will give warning. Some compilers will just let it slip and execute it, and you get nonsense printed on the screen. Okay, so this is the drawback, okay, of this printf way. But the nice thing that you have is formatting. So you realize your string literal, you can write it quite easy to read, right? A colon, then the result, B colon. Okay, so it's very easy to read. Okay, so the pros is formatting, con is not type safe. Now let's look at the C++ way of doing it, cout. So cout, we don't have to worry about whether this variable is integer, this variable is a double, we use the correct thing. It doesn't have to matter, right? We don't have to worry. All we do know is this, right? You see, take my text literal string, I shove it into cout, followed by same operator, I followed by this. So this C++, they will do the correct conversion needed. You look at this, oh, this is an integer, then it will display integer. Down here, you'll say, oh, this is a double, then you display double. So it's type safe. And so there's no type conversion or of going on here. C will do the correct conversion. Down here, the old way is not type safe. There will not be conversion. So this D, if you print the wrong thing here, you get very funny results. You all can go and try. Okay. So, but the cons is again, this whole thing looks very verbose, right? In fact, if you compare the C code, this one with this one, they print exactly the same thing. But this one looks very succinct and nice. Okay, this one very verbose, so many arrows, very hard to read. Okay, so pros and cons, up to you which one you want to use. Okay. Of course, like I said, you can mix and match. So you mix and match, then you include this, you include this, you include this, right? You can mix and match. So you can use C out, you can use printf. Right. Now, string literal, like I said, this quote and quote cannot span multiple lines. So even though C is sometimes, okay, it ignores white space, but within a string literal, you cannot have this. Your compiler will complain. Okay, so what if you want to use a new line? So with printf, you print this special character, like \n, it will give you a new line, okay, character. For C++, okay, C++, the new line is this NL thing down here. This NL is a special character, it's a special variable that contains the new line character. Okay. Now in C++, if you have adjacent string literal, it will be concatenated. Concatenated means the strings will join together. So you look here, this allows me to write my string literal in multiple lines, because the moment I close it, to C is the end of the string literal, right? So any white space behind and in front, C doesn't care. Then it immediately sees another open and close string. So C++ will join this. So how you join this? Notice that there's no new line here, because I close here and open. There's no new line and there's no space. That's why these two words are next to each other, right? So here also, comma, then N, here I appear. So immediately after comma, the next character is W. There is no new line, okay? Because everything here, there's be a new line somewhere here. This is all outside the string literal. Okay, so you cannot have new lines inside string literals. Okay, now what's escape sequence? So notice that, oops, oh, I pressed something wrong. Let me try to go to slide. Is there a go to slide? No, subtitles. Okay, so I clicked something wrong. Okay, here. Okay, let's talk about escape sequence. So with C, I mentioned that if you have a \n, this will be an escape sequence. Okay, this will be a new line. Okay, so in this sense, okay, someone asked a question. The first one doesn't print any new line, because printf doesn't print a new line. Just because you put printf on different lines doesn't mean the output is a new line. Okay. Okay. Oops. Oh, someone says I'm missing a semicolon. Yes, I'm missing a semicolon here. I'm missing a semicolon here. Okay, there should be a semicolon here. Okay. All right. So let me see. Hold on. That's my mouse disappeared. Okay, give me a moment while I fix this thing. Okay, I put a semicolon back already. Okay, so it's semicolon here. Okay, so new line is new line. CR is carriage return. Now, what's the difference between carriage return and line feed? Okay, the style poem, we will talk about it in another lecture. Okay, so what is this carriage return and this line feed? Okay, so now both of them is a bit odd. Again, this is to do with Windows and Unix and Mac. What is a new line, right? So in Windows, okay, Windows, a new line is \n followed by \r. Now, what is the difference between new line, which is a line feed, and carriage return? Okay, do you all remember using typewriters? Who here remember using typewriters one? You all should be familiar with typewriters. The younger kids, they don't know lah. But typewriters, you type right, reach the end, then you hear a ting, right? The ting tells you are very near the end, correct? You reach the end, you will pull this lever down, right? Take this lever and press. Okay, you push this. Okay, when you type a typewriter, does the okay, what moves in the typewriter? The paper moves, right? Right? And nowadays your printer, the printer head move, but when in the typewriter, your typewriter move, the entire cartridge move, or the carriage move to the end. When you push a button, the carriage will move to the end. Ding, right? This is your carriage return. Carriage return means move to the start. But then at the same time, when you push the thing in, you go to the start, then reach the end already, you push the lever a little bit more, the paper will feed, the paper will roll up. Now that is line feed. Okay, so there's a difference. Carriage return means go to the start of the same line. Line feed, then twink, go to the next line. Okay, so sometimes these two code mean different things. So in console, if you use new line only and if you use carriage return and you don't use new line, then you overwrite. Okay, you call overtype. Or what you have. Okay, so in Windows, your text files have \n, \r. In Unix, they only use \n. In Mac, they only use \r. So it's very confusing. So if you write a program, okay, in your Visual Studio Code and you save in your Windows computer, then you can email to your friend who's using a Mac and he opens up. He might see like double lines. And because the line endings are different. Anyway, it doesn't really matter to see, but again, your look a bit different. Okay, so this is the thing. Okay, horizontal tab is just jump to a certain space, right? Vertical tab, and okay. Now this is a backslash, because backslash has a special meaning, right? So if you want to type a backslash, you need to backslash the backslash. Then this will be a backslash. Okay. The home shortcut is just a way, it's just a keyboard input. Okay, it's how your editor reacts to it. Okay. This one is for displaying output. So yes, sometimes the carriage return has this thing about moving the cursor to the front again. Okay. So for us, for new line, we just use \n. Okay. It's good enough to give us a new line. Okay. So in today our modern editor, when you have a new line, you have automatic carriage return. If you just use \r, your cursor will go to the front. Then anything you display will overwrite the previous text. Okay. Now this is single quote, this is double quote, because like I said, quote starts and ends the string, right? So if I want to have something like if I want to use double quote inside, I'll put a backslash and put double quote. So this double quote will not terminate the string. Okay, we can continue and put this. Okay. Question mark. Okay, you can escape question mark, because if you want to put two question mark together, sometimes there's a special meaning, right? Single question mark, no problem. But if you put two question mark, then you might have a problem. Okay, some special meaning. So if you want to put many question mark in your string, you must put backslash. Okay. So if you do this backslash question mark n, it just means it's just question mark and n. Okay, because the backslash, okay, relates to this question mark. So it's just like a question mark n. If you put some wrong character sequence, I think, okay, it again depends on compiler whether they will give you an error or not. Okay, comments is not backslash, comments is forward slash, wrong direction. Okay, forward slash is comments, backslash is escape character. Okay, so but of course, escape character occurs only within a string literal, where you put in the quotes. Okay. Okay, so remember the format that we use, in printf. So these are the common ones. D is integer, F is a floating point. Okay, notation. X is for hexadecimal, C is for character. But if you want to print a percent, you must percent the percent. Okay, so that you can get the actual percent character. Okay. This is not very important, but it's good. It's good to know the format thing. So you put a percent 5D. Basically, you're saying I will print 5 spaces. Okay, so you leave empty spaces here. If you say %05D, it means that the empty space you put 0. So you print 0, 0, 1, 2, 3. Okay, so this is how they use the formatting. For float or double, 0.2 will just mean I round off to 2 decimal place. I mean, I can put 0.3, 0.4, it's up to you. All right. So this is just some. Of course, you can Google and find a little bit, a lot of formatting characters and all that. But this is just a common one. Okay. Okay. Whether this is correct, you can try lah. Write a small C program. Okay, and run and say whether you can say please say hello world. Okay, and see how it goes. Okay, so that's about displaying. I'm thinking whether we should take a short break now. Okay. Okay, maybe we'll go through the first condition first, the if. Okay, one condition. Then we'll take a short break. Okay, because we are not yet 1 hour in. All right, so those were just the not really introduction now. So we talk about some of the housekeeping stuff like printing and displaying and all that. Okay, so now let's go back into our elements of programming. Okay. So as you recall, elements of programming, we have mostly 3 different elements, right? You have a state. Okay, so for us in C, it is the state of the computer, basically the memory, which we access through variables. Okay. As another state, basically the program, which means which instruction is the state is the computer going to execute. Right? It's not just the variables, it is which statement, okay, the program is going to execute. Okay. And then we have some means of mutating the state. Basically, we can manipulate the variables. Okay. Then the last thing which we have not talked about yet is controlling the flow. This controlling the flow basically controls which instruction the program is executing next. Okay, so this is called control flow. All right. So control flow, normally your program executes sequentially, right? You have a bunch of instructions that we have. So you one instruction, next instruction, next instruction. This is how it happens, right? So first you read a module, right? Like TIC1001. Then you will go and do the assignments. After they're done, you take the exam, right? So it's a sequential flow, one after the other, after the other. Okay. Now, control flow can be conditional. Means instructions doesn't always have to occur one after the other. In fact, if that happens, it's not really a program, it's more like a calculator, right? One after the other. So what we want to do is have our program to react, to inputs react to certain circumstances. So it's a condition. So for example, are you exempted from the module? This is not exempted. So yes, I'm not exempted. So I will go through here, read the module, do a something exam. Okay. Maybe if I'm exempted, so I will skip all this. Sorry, skip all this. Skip all this. I can't write on this thing. Okay, skip all this. Okay, and come here. Okay, so basically it's a branch lah. It's like a fork in the road. I can go here or I can go here. This is called a conditional condition, right? So this branch. Now, if the condition goes backwards, for example, you take exam and you fail, you go backwards. Okay, so when you go backwards, you have to go through everything again and you finally come back to the condition, right? So this is what we call a loop. Right. So previously the condition is forward, right? This is forward, right? You jump forward. So to jump forward is like a branch. You come down, you go here or go here. Eventually you will meet up again. Okay. If the branch is backwards, then you will have to go through the same things again, right? So you come here. Oh, I got a branch. I go backwards. Okay. So this is like a loop, right? You go round and round and round and round. Okay. So in a sense, all these sequences keep repeating as long as condition is true. Right. Now, in the past, when you write programming, we actually have this branch condition where we tell the program, I want to go to a particular instruction. The problem with that is it makes it very difficult and confusing, right? Imagine you can just go to any instruction you want. It's very confusing to write programs that way. That's why these days, modern programming language don't have explicit branching or explicitly jump to some instruction. Instead, they give you a set of statements, okay, to manage your control flow. Okay. Now, before we talk about this set of statements, we first need to understand what is a condition. How do we represent a condition? Okay, so this is where we talk about our conditional expression. So if you recall last week we talked about arithmetic expression, right? Plus, minus, divide, multiply, modulo. So here we have our conditional expression, which is sometimes they call it a relational operator because it talks about how two operands relate to each other. So this is definitely your more than equal, less than equal. This is your equivalent. This is your not equal. So this is a bit different. If you use equal, it means assignment. Double equal means is it equivalent in value? Okay. So example, A more than 5. Things like this. You use variables and check all this. Okay. Again, you can also ask whether 6 is equivalent to a real number 6.0. Now, all these are expressions, and all these expressions have a type. Okay, they have a type. Just like how your arithmetic operation have a type. Okay. So what's the type of all these expressions? They are a special type known as a bool type. The bool come from this guy, I don't know, his name is Bool or something, George Bool or something like that. Maybe not George lah, but some Boolean. Okay, his name is Boolean. He's the first guy who thought about who came up with the concept that, oh, there's this logical thing called true and false. Okay, so there are this on top of just mathematical numbers, there's this true and false value when you talk about logic. Okay, so only two possible values in a Boolean: true and false. Okay, in a C99 C, okay, you must include this special directive to use this true and false, but that doesn't matter. We are working with C++ in our course. So C++ built in have true and false, okay, have bool type, so no problem, right? So bool, you can declare your variables to be bool. So when you declare a variable overweight, with bool, you can say overweight is true. Okay, so overweight has this logical value true. You can do this as well. Mass, okay, this is the formulation for BMI, mass divided by height square. If it's more than 60, then you're overweight. Okay, I'm not sure whether this is accurate. Okay, but basically, this whole expression will be evaluated to a true false value. Okay, if you do not initialize the bool, what it contains, I don't know, right? Because it's undefined. Again, like I said, anything you don't initialize is undefined. Depend on your compiler. Some compilers are very kind, they will initialize to false for you. Some compilers is not. So random lah, 50% false, 50% true, so you don't know. Okay, so that's a problem with leaving your things uninitialized. Right, so I always encourage you, every time you declare a variable, just go and initialize. Just type a few more characters. Doesn't matter one. Okay, this few more characters you type might save you a lot of agony if a program that doesn't work correctly. Okay, the worst thing is your thing don't work correctly. You spend one whole night trying to figure the error, then you realize, oh, I forgot to initialize. That's why it worked on my computer, it does not work on cosmology. That's the worst thing that happens. Okay, so just initialize your program. Now, let me explain to you some interesting quirk. Okay. This quirk is a quirk in C++. Actually, it's also a quirk in Python. And maybe some other languages, they tend to follow this quirk because C has this quirk. So most languages, they're trying to follow the tradition, their C sets, right? So what happens is that actually true and false, they are actually logical, not logical, they are literally equivalent to 1 and 0. Right, so you can go and take true plus true. Okay, true plus true, you get 2. This will become 2. Okay, because internally, this true has a value 1, a value of 1. False has a value of 0. Okay, so this is how it works internally. Okay, internally it has this. So with this, there's an implicit conversion. Remember from integer type, okay, last week we talked about implicit conversion, right? From integer, we can convert to bool. There's some kind of conversion in between. Yeah, so instead of using true or false, okay, note the true or false that you wrote is different. Case matters, right? Okay, for C, case matters. So your true must be all small letter. You type big TRUE, that is incorrect variable. Okay, so yes, 1 and 0 can be used in place of true and false. Okay, but again, there's implicit conversion. Basically, if you have integer 0, it will be implicitly converted to false. Anything else will implicitly converted to true. Okay, so okay, this is the implicit conversion that happens. Okay, so last week we talked about implicit conversion between a double and int. This is another conversion between Boolean, okay, or int to Boolean. So with logic, of course, we can have some logical operators. These are operators that deal with Booleans. Okay, so previously your relational operators deal with integers, right? Numbers, right? Numbers versus numbers. This 1 is more than 2 and all that. Okay, but this one deals with logic. So this thing is AND. Now in C++, you can replace this fancy operator with this operator keyword called AND. Okay, C++ understands AND. Or you can use this double pipe, is or use OR. Okay, so C++ 11 recognizes all this as your operator words. Okay, so it's a bit easier for people to read rather than this two vertical bar and exclamation mark. Okay, vertical bar I think is above your enter key. Okay? So why is this double AND? This means AND. So for this expression to be true, both A and B are true. So this reads a lot like English. Okay, only by uppercase or small case. Uppercase will just mean it's a variable called TRU with a capital T. Right. So down here, A and D is all small case. So if it's all small case, this is the operator A and D. If you type A and D, then this is your variable A and D. So it's very confusing. Okay, so in C, everything must be all small case. Then this is the operator. Just like if okay, or later you talk about that's like int int. It's all small, right? You write big int, then C this might be a variable or something. It's something else. Okay, so some languages, again, like I said, different languages have different ways of writing the keyword. Okay, so some languages must use caps, some do not need, but in C, all must be small letter. Okay, so this is C, like C. All right, this double line is or, so A or B is true. Basically, as between A and B, at least one is true, it'll be true. Okay, exclamation mark A is not A. So if A is true, become false. False become true. Okay, so with this, we can actually write a truth table. Like a truth table, basically, it has two inputs, right? This input 1, this input 2. So for AND, both inputs have to be true before the result is true. Okay, and right? This and that is very English. Or either or will work, right? So as long as one is true, okay, the result will be true, right? So not basically switch it around. True become false, false become true, right? This is what not is. Okay. No, this or is not either or. Okay, it's not only one is true. You realize this or here, even this both true is true. So A or B. So as long as one is true, it's okay, right? So in English as well, this is A or B. In English, when you talk about this or that, either one is okay, right? If even both also can, right? As long as one fits the requirement, that is correct. Okay, what you're talking about exactly only one is true is called an exclusive or. Okay, we'll not talk about it in the class. Okay, exclusive or means only one and only one is true. That is different. So exclusive or, this will be false. Okay, but we're not talking about exclusive or here. We're talking about the general or. Okay. Okay, let's take a look at some examples. So BMI. Okay, so BMI, if your BMI is more than 18.5 and it is less than 24.9, then you acceptable weight. Okay, so this is a acceptable weight. Or I can write this way. Exactly the same, right? How about this way? Are they all the same? Now, this one, I don't recommend writing this. Personally, I don't like that because it's very confusing. You see the sign switch, quite confusing, right? If you're trying to figure out what's going on here, can be confusing. This one is the acceptable way, right? Because I put all my signs in. So it's like maths, right? You know that BMI must sit somewhere between 18.5 and sit between here, right? So it's quite easy to read. Right? So once you see, it's quite easy to read. This one is incorrect. Now, in some languages like Python, this is acceptable and correct. But this is not Python. This is C. So how does this work? Okay, let me show you how this works. So if your BMI, say, okay, so you are trying to debug this. Okay, if you debug this, okay, say your BMI is 20, and you run this thing will become true. So wow, my answer is true, very good. But if your BMI is 50, okay, or say your BMI is 10 and you run, or 10, you'll say false. Okay, so of course we must try lah. I mean, when we do our testing, we don't just test with one value, right? We test with all possible value. So this is the boundary, right? I want to test a value beyond the boundary. I test a value between the boundary. I test one above. You test with 50, or maybe just put 30 lah. When you type this into here, if BMI is 30 and you run this will become true. Any idea why? Okay, so this is C. Why is it 30? Let me step you through this. All these are binary operations, right? They are like math. So they are no different from something like 1 plus 2 plus 3, right? So in math, when you do 1 plus 2 plus 3, what do? You do left to right, right? Compute this first. Get the result, then you compute this, correct? So same thing here. These are all operations. So C will compute this first. 18.5 less than 30 it is? True, right? True. So true. Now, true less than, okay, because this is true, implicit conversion, true is 1. 1 less than 29.9, 24.9, true. So this whole statement is true, even though BMI is 30. Right? So you cannot write statements like that. Even though you write statement like this, there is no error. The compiler will not say this is error. This is actually a valid expression. But then the result is not what you intend. Okay, because it executes this first. Then it executes this. So this is not what you intend. What you intend actually is this, which is why we put the brackets, right? So let's say BMI is 30. Okay, so this will evaluate. This will be true. Correct? Because of brackets here, this will evaluate. This will be false. Okay, I put small letter t. This will be false, right? True and false, answer is false. Okay, correct. Okay, so this will be false. Okay, so this is the way we write it in C, C++. I know some of you with Python background, Python will look at this and Python will translate to this. Okay, this is what Python will do. Okay, so but then this is not Python, this is C. So the way it behaves, the behaviors are all very different. Okay, so now you know the reason, right? Because this is treated as one operation. It goes left to right, right? So after you do this operation, the answer is 1 because it's true, right? Then later on, you find this one is also true. Okay. Yes, first statement is valid. I mean, you can check lah. If BMI is 30, this is true. If BMI is 30, this is false, right? The problem is hard to read, right? Harder to pass, right? Because your BMI, because normally you write 18.5 BMI, then 24.9. So once you look here, you know that BMI must sit between these two values. Down here, it's quite confusing. Imagine you put the other way around. You put BMI less than that and this, so it's like very disjoint. Okay. Okay, so now I talk about short circuiting. What is short circuiting? C is very lazy. Most programming languages are actually very lazy. It only does just enough work. Okay. What does it mean? So if A and B, suppose you have a statement A and B. If your A is already false, then obviously A and B is false, right? Because AND requires both to be true. So if A is already false, C does not even look at B. It doesn't even evaluate B. Okay, so B could be some function call, with some mathematical thing. You will not even evaluate. You just say false. Okay, this is a shortcut. Same goes for A or B. All only requires one of them to be true. So again, C will evaluate left to right. If A becomes true, now if A becomes true, then the OR naturally becomes true. So B is not touched at all. Okay, so this is what happens in short circuiting. Okay, there's no need to execute B. Okay, so some example. For example, this BMI more than 224.5 and is smoker. So maybe you want to check the health of the person. So this is overweight, right? So if the person is not overweight, okay, then this function is smoker is never executed. Means they don't even check whether the person is a smoker or not. Okay, it's never executed, right? How about this one? Or, okay, so you're checking whether the person is underweight or is a strong person, right? So if the person is already underweight, sorry, it's not overweight, okay? So it's not overweight, then this is true. Right? So if this is true, then this one will never be evaluated. Okay. Here, basically, if this is false, this will not be evaluated. If this is true, it's strong will never be run. Okay. So this is the explanation. Okay, I think we can take a short break here before we come back and talk about the conditionals and the loops. All right, so what we talked so far is basically how to express this conditionals. I mean, what is a true false value. Okay, so for the case just now, if BMI is 24.5, okay, so if BMI is exactly 24.5, will this be true or false? This is false, right? Correct. So if this is false, then the first one is false. Correct, it's false. That means a smoker will never be caught. Okay, so this is correct. If BMI is equal to 24.5, this first part is false. Okay, so yes, so good that you pointed out. You must be very careful about these conditions, the equivalent, right? So when you test this thing, right, you will be equivalent. Okay, syntax error cannot be ignored, right? This is not like Python. And in fact, for Python, syntax error also will not be ignored. Okay, because everything must be compiled. Okay, if you record, the program must first go through a compiler to translate the machine code. If there's syntax error along the way, the compiler will say, oh, I don't understand. I cannot complete the translation. Means your program will never be able to execute. It will never even produce for you the executable file. So any syntax error, your program will never be able to run. Okay, so do you use this double ampersand or the AND? Okay, for C++, it's up to you. They are both can be interchangeable. Right, so for C++, you can use either way. Okay, just don't use a single ampersand. So ampersand is different from a single ampersand. Okay, or is different from or. Okay, so these two are not the same. These two are not the same. There is a special operator of this, but we will not talk about this in our class. Yes, it's a bitwise operator, so we will not talk about this. So sometimes, if to be safe, maybe don't use double N use the AND. Okay. Okay, so we will not talk about this bitwise thing, at least not now. Okay. Okay, so let me let's start a break now lah. So just now was about 7:35, so we'll come back at about 7:45. Okay, so normally in a break I will play some interesting video, okay, for you all to watch. Last week we watched the what's that bicycle video, right? Okay, let me see, bring up some other videos for you to watch. Where's my playlist? Okay, let me play this. Oh, let me change my screen share. Okay, got this nice video.
It's 4 a.m. and the big test is in 8 hours, followed by a piano recital. You've been studying and playing for days, but you still don't feel ready for either. So what can you do? Well, you can drink another cup of coffee and spend the next few hours cramming and practicing. But believe it or not, you might be better off closing the books, putting away the music, and going to sleep. Sleep occupies nearly a third of our lives, but many of us give surprisingly little attention and care to it. This neglect is often the result of a major misunderstanding. Sleep isn't lost time, or just a way to rest when all our important work is done. Instead, it's a critical function, during which your body balances and regulates its vital systems, affecting respiration and regulating everything from circulation to growth and immune response. That's great, but you can worry about all those things after this test, right? Well, not so fast. It turns out that sleep is also crucial for your brain, with 1/5 of your body's circulatory blood being channeled to it as you drift off. And what goes on in your brain while you sleep is an intensely active period of restructuring that's crucial for how our memory works. At first glance, our ability to remember things doesn't seem very impressive at all. 19th century psychologist Hermann Ebbinghaus demonstrated that we normally forget 40% of new material within the first 20 minutes, a phenomenon known as the forgetting curve. But this loss can be prevented through memory consolidation, the process by which information is moved from our fleeting short-term memory to our more durable long-term memory. This consolidation occurs with the help of a major part of the brain, known as the hippocampus. Its role in long-term memory formation was demonstrated in the 1950s by Brenda Milner in her research with a patient known as HM. After having his hippocampus removed, HM's ability to form new short-term memories was damaged, but he was able to learn physical tasks through repetition. Due to the removal of his hippocampus, HM's ability to form long-term memories was also damaged. What this case revealed, among other things, was that the hippocampus was specifically involved in the consolidation of long-term declarative memory, such as the facts and concepts you need to remember for that test, rather than procedural memory, such as the finger movements you need to master for that recital. Milner's findings, along with work by Eric Kandel in the 90s, have given us our current model of how this consolidation process works. Sensory data is initially transcribed and temporarily recorded in the neurons as short-term memory. From there, it travels to the hippocampus, which strengthens and enhances the neurons in that cortical area. Thanks to the phenomenon of neuroplasticity, new synaptic buds are formed, allowing new connections between neurons and strengthening the neural network where the information will be returned as long-term memory. So why do we remember some things and not others? Well, there are a few ways to influence the extent and effectiveness of memory retention. For example, memories that are formed in times of heightened feeling or even stress will be better recorded due to the hippocampus's link with emotion. But one of the major factors contributing to memory consolidation is, you guessed it, a good night's sleep. Sleep is composed of 4 stages, the deepest of which are known as slow-wave sleep and rapid eye movement. EEG machines monitoring people during these stages have shown electrical impulses moving between the brainstem, hippocampus, thalamus, and cortex, which serve as relay stations of memory formation. And the different stages of sleep have been shown to help consolidate different types of memories. During the non-REM slow-wave sleep, declarative memory is encoded into a temporary store in the anterior part of the hippocampus. Through a continuing dialogue between the cortex and hippocampus, it is then repeatedly reactivated, driving its gradual redistribution to long-term storage in the cortex. REM sleep, on the other hand, with its similarity to waking brain activity, is associated with the consolidation of procedural memory. So based on the studies, going to sleep 3 hours after memorizing your formulas and 1 hour after practicing your scales would be the most ideal. So hopefully you can see now that skimping on sleep not only harms your long-term health, but actually makes it less likely that you'll retain all that knowledge and practice from the previous night. All of which just goes to affirm the wisdom of the phrase, sleep on it. When you think about all the internal restructuring and forming of new connections that occurs while you slumber, you could even say that proper sleep will have you waking up every morning with a new and improved brain, ready to face the challenges ahead.
Okay, while we wait for the rest to come back from the break, let me just continue with this. Afternoon class, yes, will be 3 to 5. Okay. Okay. Someone say how to make C run through the whole condition. Cannot. Okay, the shortcut is built in to C. Okay, it is built into the language itself. Okay, the way it works. Okay, so I'll take a few minutes to talk briefly about this course. Actually, I want to talk about this on the first lecture, but so far I think we ran out of time. Okay, let's try an experiment. Okay, so even before we talk about if and else condition, when you look at this, can you sort of understand what this code does, right? You can say integer age, input your age. I don't know what scanf is, but it seems to be reading your age, right? Input age, so you probably read your age. Figure whether your age is above 18, print whether you show that you can vote, otherwise show that you cannot vote, right? So it's quite easy to read this code, right? Okay, quite easy to read program code. Okay, but like I said last week, right, people find programming very hard. Okay, because it is like this Reversi or Othello game, right? A minute to learn, but a lifetime to master. Okay, so as like an analogy, right? When you drive car, okay, driving car is very easy. Why do you need expensive lessons, right? Because car is very simple, right? I can teach you to drive car. Turn the steering wheel left and right, your car will turn left and right. You press accelerator, your car will go forward. You press brake, then your car will stop. Okay, I mean nowadays automatic car don't even need to use clutch. Okay, so like it's like driving a Tesla. Okay, so drive car is actually very simple. But we all know it is not the case, right? You cannot learn how to drive car from reading manuals, read textbook, or watch YouTube. You need to go and take expensive lessons. Someone must train you in driving the car. Okay, so this is the case for programming. You can watch all the lectures you want. You can read all the books you want. But until you actually go down to write code, try to solve problem, okay, you will not be able to learn how to do programming. Okay, so I think this one I talked about last week already. Okay, so this one I also compare between a master chef, okay, and basically simply following a recipe lah, in the way it is done. Okay, so okay, basically, so when you watch cooking show or study recipe, it doesn't make you able to cook, right? You can watch all the shows you want. This is Yan Can Cook, so I put Yan Can Cook here because you all will remember him. Okay, the young folks will not know who is Yan Can Cook. Okay, they all know Gordon Ramsay, Hell's Kitchen. Okay, so there's no secret to success. Okay, so it is all practice, practice, and practice. Right. Now the problem with this is I just show you all the video, right, about sleep. The problem I think for our BTech, okay, the part-timers, is that the problem is you don't have enough time. Right. So for MC module, you're expected to do 10 hours per week. That is expected. But realistically speaking, programming is like a task that's new to you all. Okay, if the full-time students need 10 hours, maybe you only 15, maybe you only 20. So programming is not something, I can't say 10 hours, everybody need 10 hours. Maybe the smarter ones need 10 hours. And these 10 hours basing off the full-time students need 10 hours, right? Maybe you all need a bit more. Okay, the problem is that you are taking 3 classes per week. So that's already 30 hours per week, right? You add your 40 hour per week job, right? So if you're working part-time, I mean, if you're working full-time, at least 40, some of you go to 50, 60 hours, depending on work. Already 70 hours per week. So 10 days, 10 hours every day is spent fully dedicated to work or studies, right? So for example, you sleep 6.5 hours or 7 hours. Okay, who here actually can sleep really 7 hours? Right? Might not be possible. Okay, you have your breakfast, then you travel to work, you work, okay, all the way 1 hour lunch break, then you work, then you travel, okay, you attend lecture at night. Maybe now no more travel lah. You can watch lecture on the way home. Okay, that is if you are taking public transport. Then go home and then some time to wash up and go to sleep again. Okay, so this is your 8 hours sleep. Okay, from here from 11 to 7. But I know nobody sleeps at 11, right? Most of y'all will be much sleeping later. So the thing here is if you have work, you have class, already your time is very tight, very tight. So it's no joke trying to juggle studies and work at the same time. Okay, as you can see here, maybe only Sundays, then you don't have work to do. But you have no work, then you have to do all your homework and all your assignments. Right? Lecture, I think you have lecture 3 times okay, 4 times 4 times a week, because our class is lecture and then Saturday lab. So that's 4 out of the 7 days. Right? So the remaining hours or days you have, you'll be dedicated to doing all your assignments, doing all your homework. Right? So the problem is this. So I share you some study hacks. Okay. The problem is so the video shows sleep is actually very important. So it seems counterintuitive to, oh, you have a lot of work to do, like all this study, catch up, you don't sleep. But actually, it's actually very counterintuitive, right? Because when you sleep, you actually allow your mind to process, to store what you have learned, right? So it could be takes a lot of discipline. Okay, even if you cannot solve your problem sets, never mind. Okay, please get your brain to rest, because if your brain don't rest, then tomorrow you wake up, you're not productive, you cannot sleep. Then when you're not productive, what do? You take longer time to finish your work. And then if you take longer time to finish your work, you sleep later. This is a vicious cycle, right? Okay, so it is very important, right? So even though you have work, you have studies, you have homework to do, okay, please make an attempt, okay, to actually rest your brain. Because I think in school, you need to use brain power more than ever. So you need to have a sleep, okay? So to allow your brain to store and make the neural connections, right? Last week I showed you the backward cycling thing. After a while, your brain will make the correct connections, then you will get programming. Okay, you will get it in the end. But your brain cannot make the connection if you don't allow it a chance to. Okay, so these are study hacks that I want to share with you all. Okay, so do study in short bursts. Okay, don't go and spend 3 hours doing everything continuously. Your brain has a limit to how much you can absorb. Okay, so within 1 hour is not too bad, right? Spread out the learning. Okay, so study 1 hour, then go and do something else. Let your brain slowly process, okay, and fit together. It's like practicing, right? Nobody will do a marathon and go and practice 3 hours on piano just to learn piano. You know it doesn't work. Like after the first hour, it becomes not effective. Same thing for studying. Okay, teaching others is a very good way to study, because when you teach others, okay, you have to learn more than understanding. You have to figure out how to explain things to others. Okay, so it requires better understanding if you're trying to teach other people. And taking notes by hand is a important thing. I know now everybody uses a keyboard. Now we have online lecture, you can type on a keyboard. But there's this thing about taking notes by hand. Okay, because by hand is slow, it forces you to actually write. And as you write, your brain actually thinking about the words much slower. Okay, so at the same time, all this is all about trying to build your neural connections, okay, in your brain. Okay, that's why even write code, you can write code by hand even better, because the slower you do it, the more your brain, okay, is reinforcing itself. Okay, so this is okay, I overshoot a little bit of the break time, but this is the some stuff which I wanted to share last week, but I think we don't have time to talk about. Okay, so I hope this would be useful for you. Okay, let me go back to the old switch back to my lecture slides. Where's my lecture slide? This one. Okay. Okay, so we'll talk about now the conditional statements. So the first one is your branching. Right, so branching means you're going down the path, you see a fork in the road, you can choose to take which fork. So the structure of branching looks like this. So I come down, I travel down, I hit a condition. Now this condition can either be true or false. Okay, true, I execute some statements. False, I just ignore the statements, I walk past it. Okay, so the syntax is this: if. Okay, notice small letter if, open and close bracket. So if you don't put the open and close bracket, the compiler will complain. I know in some languages like Python, this bracket is optional, but in C it's not. C, you need to have a bracket. Inside here, you put a Boolean expression. But now you know whether Boolean or not, even if it's an integer, it will type convert, right, to a Boolean. Anything that is not zero, it will convert to true. Okay, so this expression here will evaluate to true, false. Okay. If it's true, then you execute whatever's in the curly bracket. So this curly bracket denotes the start and the end block. Okay, so inside here, you put many statements. They'll all be inside this true block. Okay, in Python, you use indentation to denote, but for C, you use curly bracket. Okay, so this is a true block. All right. So this is the most basic of an if statement. If something is true, then do a bunch of statements. Otherwise, just ignore and continue the rest of the program. So this is the statement block. Okay, the matching bracket denote a block. Okay. Now I can have an else. So notice true, I do true block. False, I can do the false block. So this is like a branch in the road. So I can execute statements either or. Right. So to do this, I add this else here. Notice the bracket. I must close the true block first. Then I put else. Then I start the else block and the else block. Okay, so the flow chart look like this. Condition come here true, or come here false. Okay, so this is how it looks like. Now, okay so far. Okay, any problems here? No problems, right? This should be quite straightforward. Okay. Now, I explain something about C. Notice that if your block contains one statement, you will omit the curly bracket. Okay, like this. So if this is here, basically this is one statement. Actually, in a sense, this is how it works. Okay, this is how C works. You execute one statement. But if you want to have multiple statements, you put a curly bracket to make this one big block statement. Okay, one big block statement. So if you don't need to have multiple statements, you just do this. Okay, but again, this can be quite confusing because if you accidentally go and put new lines inside, then the flow of it, okay, will be changed. Okay, so even though you can omit the curly brace, okay, we don't recommend this. Okay, it's always better to put your bracket. Anyway, just a few characters. Like I said, type a few more characters, won't die one. Okay, but you don't type a few characters, you might make some mistake. You spend one whole hour, one whole night trying to fix this mistake. Okay, it's very bad. Okay, waste of time and makes you very discouraged. Okay, so type a bit more, save yourself some trouble. Okay. Okay, so let's take a look at this thing. This function is called max. Okay, what's the input? Two integers, x and y. Output is an integer. So let's see. If x is more than y, return x, else return y. Okay, so it's pretty straightforward, right? Come in here, check whether x is more than y. If it's true, return x. If it's false, return y. Very straightforward. Okay. Notice there's nothing after the return. No more execution, because once you hit a return, the function will exit. You quit the function straight away with the return value. Okay, once you hit return, that's what happens. Okay, so notice there's no arrow coming out because you exit the function. Now we can write this function using one if only. So if x more than y, return x, then here return y. So basically it looks like this. Okay, yes, we can write this without else because our true block returns. But if you do not return, if you just display the number like this, so if you just display the number, okay, you think this is correct? Actually, this is not correct because why? If x is y and if x is 5, y is 3, yes, x is more than y, you print x, right? You display x. After that, what happens? Notice this line here. This is not a return, right? So this block is done. We're done with this block. We'll continue execution with the rest of the program. So it will also display y, which is not what you want. Okay, so be very careful between returning and just displaying. All right. So this flowchart, okay, doesn't end here. Okay, you must always continue with the rest of the program. Okay, so of course we can add another if statement here. If x more than y, do this. If x less than y, do that. But again, this is very confusing, right? So the flow looks like this. I check one time, then I check again. Okay, so the flow can be quite confusing. So we can, the better way is just use the else, right? So we just use this else here, okay, to have this kind of structure. This structure, I think, looks much easier. Okay, so you realize when writing program, there are different ways to structure your program. Some ways are easier to read, some ways are not. And we always try to write the easier way. But it's less confusing to us, it's easier for your brain to process. Okay. So how do you use logical AND in the if case? So again, BMI, say is ideal weight. Okay. If BMI is less than is more than 80.5 and BMI less than this. Okay. This way you can think of it BMI here, or you can flip it around. Okay, you flip it around, then your BMI is in the middle. Okay, so if this is correct, then you return true, ideal weight. Else return false. Okay, so your BMI is more than 80.5 and less than 24.9, then you return true. Okay. Now, alternatively, you can do this. What happened here? Okay, I move back. Okay, you look at the animation, right? I got rid of all this thing. I got rid. Okay, and just return this. How does this work? Recall this is our expression, right? Just now we talked about conditional expression, right? This one is actually okay. So if you are ideal weight, this thing actually returns true, right? This value is true. So if this is true, right? If this is true, I return true. If this is false, I return false. Might as well I just return this result. Okay, I just return this result. So this is what this thing is saying. So it's the same thing. I don't have to write the if statement. Okay, I just straight away return this conditional. Okay, this conditional expression will give true or false. I just return this value. Okay. Using logical OR means if BMI is less than 80.5 or BMI more than it, so basically it's here, right? It's outside. Okay, outside. So this is false, else this is true. Again, you can make it this way, right? Not. Okay, return not this. Okay, this one a bit more confusing, but go back and think about it. I don't recommend this. It's a little bit confusing because the negation thing tend to mess around with our minds. Okay, but sometimes people like to write this. All right. Okay, let's talk about this nested if else. Okay, what is a nested if else? So let's say we want to have three different outputs. Okay, basically check your BMI. So if your BMI is more than 18.5, then I want to check, is it less than 24.9? If it is, then you are normal. Okay, normal weight, acceptable weight. Okay. Normal, pre-normal. Else, so basically, if not, you are pre-overweight. Okay, so there's this bunch here, pre-overweight. Okay, okay. Technically, this will continue to the rest of the program, but there's no other lines after that. Okay, So else, yeah, I got lines here. Else, underweight. This else, okay, where does this else belong to? So let's take a look. This else is this block, right? It belongs to this block. So it's supposed to be here. Okay, false, underweight. Okay, then end of program is this. So basically, this structure does this. Check whether you are normal, overweight, or underweight. Okay, now this structure look a bit interesting. You have a if inside a if, which is this. So this is the entire block belonging inside this if statement, which is allowed. I mean, you can have another statement inside a if statement, and this will just be work this way. Right? So you can have nested if else inside. So this is how the flow chart looks like. But it's quite complicated, right? You look at this flow chart. Let me suggest to you another way of writing this. Okay, so same function. Okay, if my BMI less than 80.5, straight away I say underweight. Okay, else, false, come here. Okay, if my BMI is less than 24.9, then I say you are normal. Else, say you are overweight. Okay. Now this one, the structure, this flow chart looks a bit easier to read, right? I mean, as you're reading in, you just check lah. Is it here? Is it true? If not, come here. Basically, and as long as anyone is true, I will come into the body here, right? So it's quite easy to read, rather than that's not that one. There's so many paths you can take and all that. Okay. Now, in C, even though this chart looks easy to read, this code here looks confusing because you have so many level of indentation. All right. Now this level of indentation will be quite confusing. So what actually happens is we just omit the redundant braces and move the if up. So if you look at this, there's no difference one, right? Because open brace, close brace, right? Inside here is one statement, right? So this if else is one statement. So again, I said, if there's only one statement, you can omit the brace. So you omit the brace, move it there. So now it looks like a normal if else. Okay. Note that this is not elif. So Python, people come from Python background. Okay, Python has this code called elif, right? Python has this elif because they don't want the indentation to flow. So there's no elif in C++. It is else if, like that. So technically, it is two different statements, just that we format it this way, so it looks very similar to the elif. Right? Python needs this elif because Python indentation is important in Python. If you don't have this, then you will have this problem. Okay, the later elif will all be indented further and further and further in. Then you have this very, very complicated indentation to follow. Right? So Python gives you this elif command. C don't have. Okay, C is just else space if. So there are two separate statements. Okay, so again, this format now looks very easy to read. So you compare this one with the first structure that we have. Right? So I encourage you all write code like this to make it easy for your brains to think. Right? So basically, the whole point is I check condition. Is it correct? Not correct. I check the condition. Oh, correct. Then I execute everything in the block. There's no need to go here, go there, and fit the flow. Okay, so we write code to make our. I mean, it's very hard writing code lah. We don't want to make our brains think more or do more processing. All right. So at this moment, I want to, okay, let me just go through the looping thing. Then I'll talk a little bit about the cake UI thing that we have, okay, that I showed you last week. So that was a branching condition. Let's talk about looping. Okay, so recall if your branch go backwards, means you're doing the same code over and over again. So you loop. Okay, so in C, we have three forms of loop called the do while, the while, and the for. Right, this for is very different from your Python for loop. Okay, we will see later. Okay, the while loop is very similar to Python's while loop. Okay, so in a sense, when you do this while loop, you must check a true condition. Okay, while the condition is true, you will continue the loop. One thing you must take note of is you must make sure the condition will eventually become false. If not, your loop will just keep looping over and over again, become infinite loop, then the program never ends. Right? In Visual Studio Code, when that happens, it's very difficult because you must use your task manager to go and kill the task. Okay? Sometimes your Visual Studio Code can clear the task if it works. If not, then very difficult. You must go and kill the task using your task manager. Okay, so we talk about this do while statement. Do while statement is very simple. It starts with do, curly bracket. So this curly bracket denotes the body, right? Then while some condition, take note of the semicolon here. This is very important because some students miss out the semicolon, then you get an error. Okay, do while you need a semicolon because this is basically one statement. How does this work? You took a look at the flow chart. Basically, for a do while, the body will be executed, right? If you see here, the body will at least be executed once, right? At least once. This is a do while. The condition is checked at the bottom of the body. That means the while is here. Okay, it's checked here. If the condition is true, we go back to the start of the loop, which is the first line in the body. Okay, and execute again. Okay, so this is a do while. Do while the condition is checked here. But if at the end of the loop, condition is false, okay, you exit the loop. You will continue with the rest of the program here. Okay, so this is do while. Okay, so this is the comments. So example, sum to 10. Let us add numbers from 1 to 10. Okay, so sum is 0, number is 1. Do. Sum plus equal number plus equal 1, while number is less than or equal to 100. Okay, so let's check the ending case. If number is 100, we come here again, we will add sum plus 100. The numbers become 101. So then this will fail. Okay, so this will add numbers from 0 to 1. So in any loop, we always want to be careful. Okay, when does a loop terminate? We don't want the loop to run one extra round. So we better check the ending condition, the terminating condition. That's do while. Do while. Yes. While statement. Okay, notice there's no do here. So the while is now on top, right? In a do while, the while is at the bottom. Now the while is on top. So intuitively, you check the condition before you enter the loop. Okay, so there's no do here. And again, there's no need to put semicolon here. I mean, if you put semicolon here, there's no error lah. There's no need to put a semicolon here. While condition is just this. So you come in here, you check the condition first. If the condition is true, then you enter the body. Go down the body. When you're done, you go and check the condition again. Okay, so you finish everything in the body. When you're done, go and check this condition again. Only when the condition becomes false, then you continue with the rest of the program. Okay, so the only difference with do while and while loop is where you check the condition, right? Do while, the while is at the bottom. So at least the loop will run at least once. Okay. So to sum from 1 to 100 looks very simple, right? While number is less than equal 100, then you do this. Okay. All right. Now let's take a look at the for statement. So if you look at this is the while statement, right? If you look at my picture here. Okay, this is the while statement. While statement, the structure looks the same. My circle so bad. Okay, the structure looks the same for a for statement. So this for statement is the C style of for statement. It's very different from the Python style of for statement. Okay, so we do not talk about the Python style of for statement. What does a for statement have? This part here actually is the same. This part here is the same as while, right? So you see here, it's the same. The animation shows the exact same thing, right? So as we can tell, this condition here works the same way as a while loop. But a for loop introduced to you two new components, basically the init and the update. Okay, so what has happened is that you put some statements here, you are guaranteed to run this init first. Basically, you use it to initialize some variable that you want. Okay, and then before the next loop happens, before the condition is checked, update is run. Right, as you can see, update is run here. So this is very useful from a while loop because the most common mistake in while loop is you forget to go and change the condition, right? So normally we use something like a while n equals to n less than 100 or something. We forget to update n. Okay, so we forget to do that at the end of the loop. Then you try to run it, you have an infinite loop. Okay, so this for statement forces you to put an update here. Okay, so when you are writing the loop, you will make sure you fill in an update. Okay, so this is mostly a convenience. Okay, of course you can always write your while loop. Okay, you can translate between while loop and for loop. Okay, so to sum from 100, we do this, right? Integer sum is 0. For integer I equals 1. Right, you do this, you plus I. So this notation means you increase I by 1. Okay, there's I plus plus and plus plus I. These two mean different things, but I will not go into details. In fact, I don't discourage, I discourage you to write this. It's very confusing. Okay, best is to write this I plus equal 1. Okay, it's very good. But I think plus plus I inside a loop is very common. Okay, so people just do this. Okay, so in a loop, not too bad. Okay, you can use I plus plus or plus plus I. Okay, sum plus equal I. Okay, and then n. All right. So if you take a look at these two loops, like I said, while loop and for loop, they are actually equivalent. Why? In a while loop, I must make sure I initialize my some counters or something outside the loop. And I must make sure before the body of the loop, I must add this up. All right. What is plus equal? Okay. Plus equal. So A plus equal B is the same as A equal A plus B, shorthand. Okay. So this is just meaning add B to itself lah. Okay. So this is what it means. So minus equal, star equal, divide equal is the same thing. Okay. So now in the while loop, you must do this. Like I said, it can be this loop is very small. So we remember to update this. But sometimes the loop can be very long. Then you forget, after you type your code, you forget to add this thing to change your condition. Then your loop runs forever. Okay, so the for loop gets rid of that, because for loop has this thing, okay, where the in is, and then it has this update condition. Okay, so you never forget update. Okay, and the nice thing about the for loop is notice here is in I. Okay, when you have in I here, this creates a new scope. Okay, so I only exists within the body of the loop. Outside the loop, I does not exist. Okay, so in case you use I again, okay, you will not have any conflict. Okay, but a bit more of scope, I think, in the next lecture. Okay, so this is the similarity between for and while loop. Okay, whether you're going to use for loop, whether you use while loop, there's no correct or wrong. Okay, it's just your choice. Okay, personally, I prefer for loop because I forget to write this incremental condition too many times already. Then my code always run forever. Okay, so it's good to use for loop. Okay, so this is infinite loop. So infinite loop is while true lah, run forever, or for nothing. So that doesn't check any condition, it just runs forever. Okay. Now, within a loop, you can interrupt the loop. I don't recommend writing code like this, but you can interrupt a loop. Basically, you have a break. Okay, the moment you have a break, you exit the loop. So you can use a break in any loop you want. The moment you encounter break, you exit from the loop. Okay, it's like prison break. You exit from the loop. Okay, so for example, in this code, if I is more than 50, you break. So that means the moment you hit 50, this will be true, right? Okay, notice I was lazy. I didn't put a new line, but it's perfectly fine. I put the brackets. Okay, this will break. All right, so the loop will not continue. Okay, or you can put continue. Continue is the opposite of break. Continue means if there's more instruction in the body, ignore. Just go back to the start of loop. So for example, for this, if I%2 continue, then we do this. Now, can anyone tell me what this function does? I modulo 2. So you know lah, I is even or odd, it will continue, right? If not, then you just add to I. So is this adding odd numbers or adding even numbers? Is it adding odd numbers or adding even numbers? Odd. Okay, some say odd. Here, all say odd. Odd or even? Okay, let's see. Some say even. Okay, let's process this. The question is, when does this become true? Correct. So I modulo 2. So there's two cases. I is even or I is odd, right? When I is even, I modulo 2 is 0. Correct? 2 modulo 2 is 0 lah. 4 modulo 2 is 0. It's 0. If it's 0, it is false, right? If it's false, means I don't continue. Means I will come here. So even number come here. If it's odd, 3 modulo 2 is 1, right? Any odd number modulo 2 is 1. 1 is true. True means I continue. So I don't do the sum. Continue means I go back to the top. Like continue means I skip all the instructions. So what happens now is this adding all the even numbers. So please note, this thing can be quite confusing. Okay. To avoid confusion, you should put I% 2 equals to 1. You can do this. Okay, some people or just do the shorthand. So this shorthand is actually very common in programming. People like to confuse themselves so they will put this in. Okay, so please be very careful when dealing with this. Okay. Okay, so it's adding all the even numbers, correct? Okay, because if it's even, this thing becomes 0, right? And when it's 0, it will not go into the continue. Okay, so this is a summary of what we have. Okay, so I'll take this next few minutes to talk about our cake. Right, you have this very nice cake programming language, and I have some good news. I actually worked on cake throughout the last a week, and I think my cake is ready for us to play around with. Okay, so let me just share. But I have not updated the cake on your okay. Can you see the cake? Right, I've not updated your cake. Okay. Okay, so someone asked this one without bracket, how to evaluate? So again, these are all operators, right? More than is operator, and is operator, less than operator. So they work by order of precedence. So it turns out and has the lowest order of precedence. Okay, so BMI, okay, more than 80.5, okay, they will do the comparison first, then they do the N. Okay, writing I% 2 equal true. Now this is a problem. This is not syntactically correct. Because you must put double equal. A single equal means you are assigning true to I%2, which is not a correct thing. You can only assign values to variables. Right? So single equal is not correct. So Li Jia say must put double equal. Now, I%2 double equal true, is it correct? It might work, but again, that's bad form, right? Because I%2, we want it to become okay, that is bad form because end of the day, what you have is already checking whether true or false. Okay, you put an additional double equal, there's no need to write. And again, you're opening yourself up to some error. If you use a single equal, then it might cause problem. Okay, so already in the if conditional, what we're checking is whether it's true or false. So there's no need to write equal true again. Okay, if you use the double, it's not double equal, it's the double ampersand. Okay, double ampersand and the double pipe is the same as and or. Okay, you can use either one. Okay, so this is the cake code. So it's a bit different. Okay, so I will go home. Yeah, after this, I will go home and try to update the cake so for you to use. Right? So a very nice thing about the cake. So let's take a look at our function of a looping function. Okay, so let me do this. Okay, so maybe this would be our function sum to 100, right? Sum n. Okay, sum. Okay, maybe we call this sum. Okay, function called sum, right? So let's take an input called variable. Okay, so okay, we have all this. I have all these things now, but for you, you don't have. Okay, so let's call the integer n. Okay, so this is sum n, right? So I want to sum number from 1 to 1 to 10, say 1 to n. How do I do that? Right, I want to sum a number from 1 to n. That means if I put n is 5, I'll be 1 plus 2 plus 3 plus 4 plus 5. Okay, or 5 plus 4 plus 3 plus 2 plus 1. Okay, we can do either way. So what should I do here? I have n, so I definitely need some integer to contain the sum, right? Contain the sum. So I'll put a variable. I'll need a new variable to contain the sum. Okay, I will call this variable S. Okay, I won't call it sum because down here got sum, right? I will not use the same name. Initially should be 0, right? So how do I add it up? So while the n, okay, so I want to add 5 plus 4 plus 3 plus 2 plus 1. Okay, so I'll have a loop. So I can do a while loop. Okay, repeat while n is more than 0, right? Or n is more than 0. Okay, I will loop. Okay, so initially n is say 5. Then I want to become n become 4, become 3, become 2. So I want to add to S. So I have set S to, I don't set to 0, I want to set S to math, okay, this one, S to S plus N. Okay, maybe I will create a plus equal operation. Okay, now don't forget to make N, set N to N minus 1, N to N minus 1. So maybe I will go and create a N plus equal 1, right? So that'll be much easier. N minus 1. Okay, so this is basically K. Okay, so end of the day, okay, I'll put my variable S. Okay, my S. So this is basically the C code you write. Okay, it is similar to the code that I showed in lecture. Only thing I didn't use this, I used a shortcut, right? S plus equal N. Okay, so the nice thing about this now is I added this execution thing here. So you click here, execution. Okay, you type sum. Okay, let's try sum 5. Okay, and you run. Okay, so this thing runs, right? So basically, what you see here is the this is like the computer memory. Okay, some way of viewing the computer memory. So you have N is 5 here. Okay, the font's a bit smaller. Maybe I'll go and make the font a little bit bigger, so you can step through. Okay, so one step, you notice the program comes here, right? So okay, I run sum 5. So N is 5. Now I create an integer S with 0. So S is 0 here. Okay, so you go next. While loop is highlighted. So N is more than 0. Is it true? Yes, N is 5. Okay, so it's true. So it will go inside the body. So set S to S plus N. So 5 plus 5 is 5. S become 5. Next one. Okay, N minus 1. So N from 5 become 4. Okay, so down here is 5 plus 5. Next one will be N is will become 4. Okay, then after it's finished, check a while again. Then you come here. Here is S plus N. Okay, so S was previously 5, now it becomes 9, right? 4 plus N. And again, N minus 1, so N previously was 4, now become 3. So as you can see, the loop will keep looping. You can see the values in memory change until, okay, N is still 1. Okay, so you'll go one more round, add 1 to S. So S was 14, add 1 to S. Okay, then we're done. Okay, because N is now more than 0, it's no longer true, right? So we're done. We exit the function and the value is 15. Okay, so I managed to get this up. Okay, basically I took some open source software and put them together. Like I did some coding and put them together. So you can try running it for different values here. So you try N is 10. Okay, you run. Okay, then you can step through and see how the computer memory evolves. Okay, more complicated stuff like if else also can. Okay, so I do this cake thing because I understand in Visual Studio Code very difficult to trace through the program. Okay, those coming from Python, Python is a little bit easier to write or to trace through a program rather than C. So I have this very simple way of doing it. Unfortunately, you must use the cake to write these blocks because trying to interpret this requires some compiler, okay, which is very difficult. So for us, it's easier if you have this cake, okay, cake thing here. So you can take a look at this, okay, and flow through your program. All right. So right now your cake doesn't work this way. The link will be the same link. I will update the cake link. So right now your cake is basically what is it? GitHub Git page btechscale.github.io. Oops. btechscale. Oops. Okay, this is the one. Oh, where did it go? Oh, it's here. Okay, this is the one. All right, so this is your cake. Okay, so right now I don't have the execute thing here because I haven't updated yet. I basically was working on it. So I think just today I managed to get all this thing down to basic. There might be some bugs Okay, so if you find any bugs, please let me know. Right, so I'm trying to get most of these things to work. Okay, so yeah. Okay, so I'll probably update tonight or tomorrow. So hopefully you don't need to use this C tutor, right? Last week I talked about C tutor. You type your code, you visualize, then you try to run it. A bit cumbersome. So I already told this C tutor is open source, so I took the code, I merged it into a cake. Okay. All right. I think that's the end of our lecture. I mean, I already showed a summary slide. Okay, so there's nothing much to do. Okay, so bonus training again. There's bonus training for lecture 1 training. Problem set 2 is okay. Problem set 1 is due soon. Okay, problem set 1 is due soon. Problem set 2 I think is due in 3 weeks. Right. So problem set 1 is due on Sunday. We will discuss a little bit of problem set 1 in the labs. Okay, but again, like I say, if you're already done with problem set 1, don't have to attend the labs. Okay, we will talk about problem set 1. I'll ask the tutors, okay, to go through problem set 1 in the labs.